Can anybody verify that this is properly sharing my screen and that you can hear what's going on? Anybody? All right.
Need someone to verify sharing the screen.
I hope it's working. You just click a link. I only need one person to tell me if it's working.
Yep.
Okay. Right on.
You have to say something first to verify the
Testing, testing. Yes. All right. Thanks. All right. All right. So today is again kind of going to review a few things and then add on to it. We went over a lot of the stuff already. You guys, do you need me to go over statics or instance variables? Everybody understands what that stuff is? The one thing that we didn't really go over though is the why you can't access an instance variable inside of the class that a static method is defined in. So if we try and do some int here, this is an instance method of the class program. You can't access it from inside static. You can think of statics as being in a totally different section almost. And an instance variable only exists when that class is instantiated. So you have to reference it through an instance. So it's the same principle as before. We just never talked about directly trying to access an instance variable within the same class that a static method is defined in. But do you guys need me to go over any of that stuff again? I mean, we've probably gone over it twice now. If we do need to, it's totally fine.
What would you do to access that variable?
Yeah. And by the way, this is actually something that I didn't go over either. So that's a private variable. So if we have another class here, and then public, yes. And we say, I don't know, you wouldn't normally do this, obviously, but you can't get some int from here, from that instantiated class, but you can from in here because you're instantiated inside of the definition of the class that it exists in. So it's private, but it's accessible from inside of that class. So anything you do inside that class has access to that variable. So you can see that it's here, but not here. So that is one weird thing that we hadn't gone over, or one, I guess, not really exception to the rule. It's still following all the rules, but oddity, I guess you could call it. Seems like it anyway. So you guys went over equals and get hash, all that stuff, right? So we'll go over how to write. Well, first of all, does anybody have any questions about that stuff? Does it make sense to everybody?
You're basically just saying that private is class, right? That it's contained to its class.
Yeah. Yeah, exactly. So we'll go over the toString. You can make your own toString. It's just an implementation to create a string or a human readable form of the class, right? So if we have a class car and it has, I don't know, and I don't know, MP3. We'll just do something really simple. And then oops, not class. I don't even need to define that actually. So if we do override, we can see it auto-completes the toString because we're overriding the parent class. Everything has a default toString. So we need to override it. we can either leave it as is, which is going to return basically a useless, this is an object statement basically, or we can override it. So we could just simply say return string.format, and then what do you call it? 0 as doors and that's G. And then we'll say name, yours, MVG. And that's it. Simple as that. Is that zoomed in? Yeah, okay, cool. Can everybody read that, or do I need to make it bigger?
So car here, it's overriding toString from the object class?
Yes,
Okay. So everything from object.
right, exactly. So it by default inherits from object. So then we're just overriding that and saying use ours instead. And we're just returning something that says what we do. So if we, actually, let me make it a public car, and we'll say, name. Actually, you know what? We don't need to do that either. We haven't gone over this either, but this is a really cool feature. We can do this car equals new. And equals Bob. Sure. Actually, is he gonna let me do this in there? Maybe it won't. It's not going to because I have these as private. Click. And then doors equals 4 and MVG equals 23.5. And there, we've instantiated our new car, and then we say console.write line car. If we run this, it should just print out Bob has 4 doors and gets 23.5 miles per gallon. Now, notice I didn't have to call toString on there because if toString exists, it'll use it and convert that to a string automatically. It'll just call that. So Bob has 4 doors and gets 23 miles per gallon. It's as simple as that. So it's public overriding the base toString. So pretty simple.
What's an instance where you would use override?
He's not wrong. I mean,
I'm just curious in like real life, like coding for doing override or something like that. Is it just like,
well, I mean, your needs will really tell you. Anytime that you have a class that already has something implemented and you need it to behave differently or add functionality on top of it, you'd use override.
okay.
So it really, I mean, there's really depends because if you want it to be, it always depends. That's really the answer. But if you want it to be the default behavior, you just use override. Otherwise, if you want it to be the behavior only when it's wrapped as your class, then you would use new. So then when somebody, like could say, because you can wrap this as an object and just treat it like an object. So if we say,
That's what I was wondering, is just making it like one big large if I was statement.
well, if you had, yeah, it's going to be, yeah, let's see here.
Well, it kind of depends on what's there already.
Yeah, it depends on what's there, what you need it to do, how you want it to behave. Because if there are functions, like let's say that you have a method somewhere that takes, actually, it's better to explain this when car is, or object is not your base class. I don't know. Let's call this vehicle, and this has. So we'll say, yeah. And engine type. So this one is vehicle. So So then we can come up here. Type equals. Yeah.
Oh, okay, so you just create another class,
Yeah, we'll just do engine type. And we'll say this. So this overrides the object's behavior. This overrides vehicle's behavior. So if we wrap this as a vehicle, because it is a vehicle, so we can cast it to vehicle, and we run this again, it says the same thing for both, right? Because it's saying that even though I cast it to vehicle, I'm overriding the previous. So I want you, regardless of the cast, if its top level class is car, I want you to treat it like a car. But if we say that, then it's using the old one because we're not telling it to use the new, or we're not telling it to use the, whatever you call it, the override, right. And then trying to remember what the other one is.
Is there one that lets you keep base function and add to it?
Yeah, I'm trying to remember what it is now. Because there's one that basically says, use this when it's this, and use the other one when it's cast as the other one. And I'm trying to remember what it is. I can't remember. I'll have to look it up. But yeah, basically, it all depends on how you want it to behave. That's bugging me. I can't remember. I'm gonna have to look that up. But yeah, it's basically if it's a car, use this one. If it's cast as its parent or any of the other ones, use those instead. But yeah, it all depends on how you want it to behave. Because then we could also say this and as engine. Actually, let's change this back to override. How about now? What the heck? Computer is so annoying sometimes. All right. Oops, that's not what I wanted. There we go. Then actually we'll make this safe and say obj as car if the direct cast. Yeah, so this is a safe way of casting the as. So, and of course that's going to give me problems until I finish this condition. But if you use as, then this is not going to fail if it can't cast it. It'll just result in a null. If you try and directly cast it with an explicit cast, then it's going to throw an exception if you pass something that can't be cast to a car. You can say, I'll write that in a second. You can say if this name equals obj.name, not obj, it's obj. Else. So then for our custom equals, all we're doing is literally checking to see if the names are the same, which you wouldn't really want to do that, obviously, because that breaks the whole purpose of equals method. But if for whatever reason you need that, that's the only thing that you need to determine as these are the same objects, then so then you can get the equals method to return true. But then if we say okay, let's just do this. Yeah, I don't want me to do that. New vehicle. And oh yeah, what let me? I had the wrong prefix. Now it's false, false. So it still works, but if we hadn't put that as in there and we had said car object equals car J, and now we run this, even though we're passing a vehicle which can't be cast to car because it's the base class, and it's going to throw an exception and say that that can't be cast. It's an invalid cast exception. Does everybody get that? All right, cool. So, and then there's the get hash code, which is really just getting a string representation, string identifier of that object. But those can be based on any number of things depending on who implemented the get hash code method. So just because two hash codes are the same doesn't mean that an equals comparison would be the same, because they may be two separate objects, but maybe the hash code is based on the values internally, and those hash codes would result, or those values would ultimately end up in the same hash code. So if we had, and I'm going to write a really, really simplified hash code, and then we'll say, oh, not in here, my bad. And we're going to do the same thing for the sake of this. Actually, we could even do this so that we're just doing. That's not what I wanted. Hang on. There we go. Yeah. So if we did this, get hash code. Oh yeah. Okay. So then default probably obviously going to try and do that, but the very, very simple. I'm not doing any calculation or anything. I'm just going to simply put a condition in here. If name equals Bob, I'm not going to do if. My bad. I want to do a ternary operator. Then 1 else 0. So this is obviously simplified. You wouldn't want to do that. That's way too simple. There's no distinction there. It's just everything is a 0 unless his name is Bob, and that's a very terrible way of doing this. But it's just for demonstration. So then in here, if we say and do car.hashcode and do hash. We can see that they're both the same, but they're not the same object. So it's not a way to compare that. But it is a way to compare if you want yours to only care for get hashcode to have the same hash codes if all the values inside are the same, then you write your hash code to do that. Otherwise, just leave it however they have it. But yeah, get hash code, we can see that one's 1 and the other one's name doesn't equal Bob, so it's got a different value.
With the default equals method, it's referential equality, right? It tests whether it's the same object.
Right.
And if you override it, you want to override it such that like not testing referential equality typically, or do you want to do that?
Yeah, I mean, I don't know what the point of overriding it would be if you're going to leave it the same. I mean, maybe you add some conditions on top of that, but I don't know how that would make any difference.
So if you override equals, you're just testing to see if these things, two different objects look identical.
Right, exactly.
So whatever.
Yeah.
You want them to.
Yeah, and again, the needs of your class are going to inform how you want to do that. I mean, I can't really think of any instance where I felt the need to override the equals method or even the get hash code method. But that's because I don't primarily use get hash code. Although it is useful when you want things stored in a dictionary, which is one of the examples they brought up, right? If you want things stored in a dictionary and you want to use the hash code of a particular class to retrieve a value, then if you're basing your hash codes on internal values, then it doesn't matter whether it's the same object or not. You can use the hash code from 2 different objects that have the same internal values to get the same value out of the dictionary. So I can demonstrate that very simply too. I don't even know what the hell we would call it. It's just called string. Let's say 1 Mazda. And what does it not like about this? Oh, hang on. So we have a dictionary that takes an integer as a key and a string, or contains a string associated with that. So if it's a 1 that's passed into it, it's Mazda. If it's a 0 that's passed into it, it returns Toyota. So one of the things that we can do, if this is our hash code generator, then by doing this, if we use an object hash code to get a value out of here, then obviously car is going to return Mazda because his name is Bob, which will return a 1. And car 2, using its hash code, is going to return Toyota. But at the same time, we can have a totally new instance of car. That name is also Bob, but is a totally different object, but still returns the same result. Which wouldn't be the case if you, because let's say you want to use these objects for whatever reason, these objects and the values that they have inside are the things that you want to use as the key to get values, because if these things are very specific, then you also need this additional information. If you used car as a key, which you can because it's an object, and you can use any object that you want, and this is car, this is, and we'll say car Mazda, car 2, Toyota. So now in this case, and why isn't it letting me go? Yeah. Syntax. There we go. So now car 3 is not going to yield any value because it doesn't exist in this dictionary. Yeah. And well, let me wrap that without throwing an error. Yeah, cool. So right now, because we've explicitly stated that a car instance must be used as a key, we'll have car in here and we have car 2 in here. So if we pass car into that dictionary as the key, as in car dictionary car 2, and then I'll do this one for simplicity's sake, and we'll say car 3, and this one's going to throw an error because it doesn't exist in there. Of course, it doesn't want to throw an error. Oh, because it's just going to say null. Anyway, so let's see what it says here. Console. You can see that car, the actual instance of car, returns Mazda. The actual instance of car 2 returns Toyota. And then that one's going to return Mazda, of course. Why? Oh. Is it because of this? No. Oh, it is because of this, actually. Yeah, there we go. It's because I was overriding the get hash code. So this just gets a hash code based on the object itself, right? So these are going to differ because I'm not overriding that method. So when you actually call it, now this doesn't exist in here. So it's going to actually tell me that the key doesn't exist. I forgot that you could actually just do this and it would use get hash code, right? Yeah. Okay, now it makes sense. So this has a very quick and easy way of getting the same values using an object rather than if you override the, oops, I gotta stop this. If you override the get hash code.
Let's see if I follow what you just did. You use the cars as a key to the dictionary.
Yeah, use the car object as a key to the dictionary, right? We have car with Mazda and car 2 with Toyota.
And each car has got to be distinct, right? It's got to be like a unique key. That's and then what? C# went and found its hash code.
Yes.
And used it to look up Mazda or Toyota.
Right.
Like two of them that were different returned Mazda because they were showing up because you overrode get hash code.
Right. Exactly. So both of these, it used the hash code as the key, which then I forgot I did that actually, but it uses the hash code as the key. And then if you pass it in there, then since the hash code resulted in the same value, it was able to get the same value out of the dictionary. And this one was different. If you don't override it, then those hash codes aren't going to be equal because it's just going to use the default object implementation of get hash code, which we can see here if we want to actually see that in action. Again, it all depends on what you're trying to accomplish, really. So these are the default hash codes from the object implementation. And then that's going to throw an exception, which it did. But if we, and of course, there we go. And I'll put this back in here, right here. And then and you can see that it's going to be 101, which result in the same, which then results in printing out Mazda. What else? I mean, it went over the, what's the single responsibility, or what do they call it? I can't remember the term right now. Basically, every class has one responsibility. If you start making it too complicated, you need to start breaking it out into multiple classes. So if you have a class that is all about math functions, then that's great. But if you start doing string manipulation in your math class, then you should probably break that out into its own class to do string manipulation. But then you could even go farther than that, and even though it's dealing with strings, but it's doing more complicated string manipulation, you could have another class that does the more complicated string manipulation. The whole point is you should keep your classes as small and specific as possible. And then once you start to find that you're not diverting, but you're going outside of the original intention of that class, you should probably take those and put them in their own class.
That's what I was actually, it has a possibility of getting pretty messy.
Yes. Yeah, it's really easy to make classes that are just so convoluted it's impossible to work with later. It's just really much easier to keep things small. I mean, obviously there's sometimes that you're not going to be able to keep it like 20 lines. Sometimes it's going to be bigger than that, but well, quite often. But you want to keep the job that class has to as narrow a thing as possible. That's really it for this class, honestly. It's going over equals, get hash code, static, which we've kind of hit on already. And that's about it. Did you have anything else to add to this? Okay. Yeah, which we've iterated or reiterated several times. So I think everybody's probably got that. Oh, well, actually, I shouldn't assume. Do you guys want me to go over anything? Was there anything in the lesson or the prep work that you guys saw that was confusing that you need a bit more information on, or that you need to drive home? No? Seems like everybody's pretty good. All right, cool. We'll call it that then.